Well, hi everybody. We're going to do a differentiation review today, starting off a new topic, differentiation, differential calculus. So let's go. Some derivatives to remember or to learn if you don't know them yet. Okay, here we go. If f of x equals k, what's the derivative? 0. Very good. What about x to the n? You tell me. Yes, n times x to the n minus 1. Very good. Now, sine x actually has a derivative of cos x. So if you didn't know that, you better learn it now, okay? And cos x has a derivative of minus sine x, okay? Is that another one you need to learn? Well, if so, please learn it. E to the x has the derivative of e to the x, which makes it a very special little beastie indeed. The derivative is the same as the function. Log x, last cab off the rank, has a derivative of 1 over x. Okay, if you didn't know that, and you can't have the log of a negative number, and you can't have log of 0, so x has to be greater than 0. Right, here's some rules for you to remember, or to learn, if you don't already know them. First, there's the product rule, the quotient rule, and the chain rule. Product rule goes like this. If you have y is a product of two functions, u and v, both of which are actually functions of x, then dy dx equals u dv dx plus v du dx, or as I affectionately call it, left d right plus right d left, and the d bit meaning the derivative bit, okay? Left d right plus right d left. Quotient rule, where you have y equals u over v, where they're both functions of x, then it goes like this. Dy dx equals v du dx minus u dv dx over v squared, or as I affectionately call it, bottom d top minus top d bottom over bottom squared, okay? Bottom d top minus top d bottom over bottom squared. That's a great way to remember it, because my students do remember it after we teach it to them that way. Now, chain rule is, look, this looks really weird, but I'll give it to you, and we'll see if we can unpack this. Yes, I know. I heard you. Now, look, just imagine if h of x was x cubed, right? But we had something inside. We had something g of x all cubed, right? G of x could be anything at all. We don't really care what it is. So what you would do is you'd say, okay, the derivative would be 3 times g of x squared, right? Because remember it was g of x cubed, so it'd be 3 times g of x squared, which is what you mean by that h dash g of x, times the derivative of g of x itself, which would be whatever it is, the derivative of g of x with respect to x, right? That's what you do. So I hope that example helps you understand all the gobbledygook. Yes, because it looks very abstract and rather horrible like that. Just use an example and you'll see how it works. Yes? Good. Some examples. We have to differentiate all these things. Good gracious me. Well, this one is going to be a product rule, this one's going to be a quotient rule, this one's going to be a chain rule, and this one's going to be a quotient rule, and I'll show you why. That one's, I've left the special one till the end. Okay, so here we go. If we say that let y equal x to the half times cos x, that's a product. Yes, u times v, where u equals x to the half and v equals cos x. Okay, then differentiate both with respect to x, and you will get that, won't you? Yes. Just look back if you can't remember those derivatives. The derivative of cos is minus sine. Now we just plug and play. By the product rule, we know that if y equals u times v, therefore dy dx equals u dv dx plus v du dx, or left d right plus right d left, and we get that. That's left, that's d right, that's right, that's d left, yeah? And you can just clean it up a bit and it looks like that. I've converted the x to the halves to root x's and made them so that I'm getting, this is x to the minus a half, so it's appearing on the denominator. It looks just a bit more friendly that way. There's A done, right? Now B, that's a quotient rule, so let's do the rule. That's u over v, where u equals x cubed, and v equals sine x. Now here comes that very complicated looking rule. Oh no, du dx is 3x squared, dv dx is cos x. Here comes the rule now. Yes, there she be. Now, that's going to be that. Now, v du dx minus u dv dx over v squared. bottom d top minus top d bottom over bottom squared. And that's going to be that. Yes? I think that's clean enough. You could take the x squareds out as a common factor if you wanted to, but that's fine. That's fine by me. That's good enough. Now, if you don't like the quotient rule, guys and gals, you could actually treat that as a product rule question by doing this. You could say, well, it's u times v, where v is sine of x to the minus 1. And then you could just do lefty right plus righty left, which is what the product rule is, okay? Now, we'll do that and show you. It actually does work out a bit complicated because it takes a lot of mucking around to work out dv dx when I show you in the training wheels version of it, which is what we're doing here in this video before you get really good at them, okay? Now, so du dx is simple. That's basically 3x squared. But here's v. I'm going to call, see, that's what it is something to the minus 1, right? The something to the minus 1. Now, you know the rule for x to the minus 1, which would be minus 1 times x to the minus 2. But this happens to be sine x to the minus 1. So you call the sine x a single symbol. Okay, and we're going to borrow w. Okay, so we're calling... we know that v is sine x to the minus 1, so it's basically w to the minus 1, which makes it very, very nice and simple, where w is actually sine x. Now, dv dw is, dv dx is going to be dv dw times dw dx. So we're chain ruling just to get the derivative of this term here, right? Now, if v equals w to the minus 1, therefore, as I was beginning to say before, dv dw is minus w to the minus 2, alright? And dw dx, if w is sine x, it'll be cos x. Now, just recapping, that's where we got to, so we can chain rule it now. We can say dv dx equals dv dw times dw dx, and it's going to be that. But we have to substitute for what w was, and there it is, right? Okay? There it is. You get that. So that's what dv dx is. Now we go back to our original product rule, lefty right plus righty left, to get the derivative of the whole of the initial thing that we were dealing with, which was that, right? So u dv dx plus v du dx, knowing that dv dx is that thing up here, will be right now. There it is. There's u, there's dv dx, there's v, and there's du dx. Now we just have to fix that up a bit. I think what I've done is I've basically I put it all over sine x all squared. Yeah, that's right, and that's what we actually got before when we used the quotient rule. Okay, so if you don't like the quotient rule, you can use the product rule instead, providing it doesn't work out too complicated. All right. Okay, the next cab off the rank is this one. Now that's cos of something. It's cos of, not cos of x. It's cos of something very confusing. So we can call it cos of blob, where blob, we'll just call that a single symbol, and we'll call it u. Okay, it makes it so nice, doesn't it? Immediately we can say that dy du is minus sine u, because the derivative of cos is minus sine. Yes? Now, also du dx up here is going to be minus 2 times x to the minus 3 plus 1. How's that? Yes? Okay. So by the chain rule, dy dx equals dy du times du dx, and off we go. Plug and play. And that's it. Okay, dy du was that, wasn't it? Yes, and du dx was that thing. Just substitute for what u was. U was that, and I think we've just about done it. Yeah, I've just taken care of that minus sign out the front by reversing the sign of those two terms there in this bit over here, okay, and put it in front. And it's all cleaned up and looking beautiful, looking spick and span and very nice. Okay, that's it, guys. Now, what's the next one? Oh, this is tan x. Yes. Now, after I show you what the derivative of tan x is, which is sec squared x actually, I want you to remember that because it's a very handy one to know. And the way we work it out is we basically do it as a quotient rule, because tan is sine over cos, isn't it? It is indeed. Now, what we're going to do now is we're going to say that's u over v, where u is sine x, v is cos x. So du dx is cos x and dv dx is minus sine x. And we're going to do bottom to top minus top to bottom over bottom squared. There it comes. Yes, right? Okay, there it is. Bottom d top minus top d bottom over bottom squared. Now just plug and play away, and look what happens. You look at that numerator. It's going to become very nice in a moment. Look! Now, what do you see when you look at that numerator? Yes, that's what you see, or you should see that. So basically the numerator just dissolves into a beautiful 1, and we get 1 over cos squared x, which happens to be sec squared x. So can you please remember from this moment on, ladies and gentlemen, that the derivative of tan x is sec squared x, right? Don't work it out, you haven't got time. But do work it out if you haven't got time and you forget, but other than that, please remember it because you're going to use it. Yes, 3 stars because it's so important. Now we're going to do some examples involving tan, right, because tan is the man, and tan is very important. Right, A, B, C, alright. Now, look, just cast your eye over this. That's tan of something, which isn't x. But the template is tan x, which gets you sec squared x. So this is going to be tan of blob, where blob is going to be u, and u is going to be 7x cubed minus 2. This one is something to the fourth. If you had x to the fourth, you'd know that that's 4x cubed. But this is tan of minus x to the fourth. So we're just going to call tan of minus x blob or u, I think. This one here, I'm going to save the surprise till last, okay? A today. Yes, now, see, that's what you do. Now, immediately you know that dy du is sec squared u, and du dx is actually 21x squared. So you just use the chain rule and you plug and play. There you go. Now dy du was, what was dy du? Sec squared u, and du dx was 21x squared, yes? Good. Now we're substituting back for what u was. Now what was that again? 7x cubed minus 2. There's your answer, guys. See? Look, when you practice this stuff, you get really, really good at it. So don't be intimidated by it. Don't be put off by it. Everything is just a matter of practice. And then you get familiar, and then you get confident, and look, it's just boringly easy then after that. So come on, that's all you got to do. Yes, practice. Now what's B? Yeah, that's something to the fourth. Something to the fourth. See, look what I did, right? Now you know what dy du is. Just look at that. What's dy du? It's 4u cubed, right? What's du dx? Well, that's looking a little bit ugly. I think we need to do some more surgery on that. If that was tan x, no problem, right? We'd say du dx would be sec squared x, but it isn't x, it's minus x. So I think we need to call the minus x something. That's blob, and we'll call the blob some other symbol. Then we'll do some more surgery on that one. Just peel the onion a bit more, one layer further. So we're going to let u equal tan v, where v is minus x. Now, du dv sec squared v, dv dx minus 1. Yeah, that easy. Easy peasy. So let's just do the chain rule. It's 3 links in this chain. dy du times du dv times dv dx. And plug and play. dy du was 4u cubed. Du dv was sec squared v, and dv dx was minus 1. Now just substitute back for what u and v are, and what you're going to get in terms of x. That looks like it. Just cleaning that up a little bit. There you go. There you go. See? Easy as. Easy as. Now the last one, number C. What's that beastly looking thing? Sec squared 5x. Okay, now, I suppose you could call that... you could call it cos of 5x to the minus 2 and do it that way, but I'm going to use an identity to do this, and you watch it, because you know we've learned in a previous video that that's 1 plus tan squared of something equals sec squared of that something. So I'm just going to turn it into something involving tan squared, right? Now, unfortunately, it's tan squared of not x, but some other thing. So I'm going to call that blob, and the blob is going to be u, right? So it's going to be y equals 1 plus tan squared u, right? Oh, well, actually, I haven't done that. I've done something else, haven't I? I've called it 1 plus something squared. That's right, I forgot that. I forgot. So basically that makes it even easier and simpler, because you need to say, yes, it's 1 plus something squared. Alright? U squared. And therefore dy du is basically, what is it? Dy du is basically 2u. Alright? Now u is tan. That's what I was getting to before, but I forgot the extra layer in the onion that I had to peel first. U equals tan of 5x. Now I'm going to call that 5x blob and the blob something else, yes? Here we go over the page now. So let's make U equal to tan V, where V equals 5x. Isn't that right? Yeah, okay, so now we can go du dv is sec squared V, and dv dx is 5, and everything's good. You watch. There's 3 links in the chain. dy dx equals dy du times du dv times dv dx, and we get that. Alright? Yes, yes, yes. Now substituting back for what u and v were in terms of x, we get that. And I think that's nearly over. All over Red Rover. There we go. Yes? Excellent. There's the answer. Very good. Now we're going to do some examples using operator notation. This is very easy. The derivative of this, which is a piece of cake, the derivative of that, which looks pretty nasty, the derivative of that, which also doesn't look too good, and the derivative of this, which looks positively mind-boggling. We will sort them all out for you, okay? Now, first one, yeah, that's so easy. The derivative of that, of x cubed plus 2x squared minus 5 is just 3x squared plus 4x. Yes? B. Now, look, this thing looks ghastly. We know what the derivative of y equals e to the x is. It's just e to the x. But this isn't an x. It's x to the minus 2. So that becomes the blob. And that becomes a single symbol to get us out of trouble. And then we use the chain rule. Alright? So we'll say let y equal e to the u, where u is x to the minus 2. Right? Now dy du is e to the u. Du dx is, have a look, yeah, it's minus 2 times x to the minus 3. Now we're equipped to do the final chain rule thingy. So we know that dy dx equals dy du times du dx. Now dy du was e to the u, and du dx was minus 2 times x to the minus 3. Substitute back for what u was in terms of x. And what was it again? U was x to the minus 2. So you get e to the x to the minus 2 times minus 2 times x to the minus 3, and there it is, right? I've just put the x to the 3 on the bottom to get a positive exponent. So there's your answer. Alright, you okay? Good. Now, in this one here, that looks like the derivative of something squared, right? And that something is going to be cos u. And we're only taking the derivative with respect to u here. So that doesn't look so bad to me. Right. So y equals cos squared u, that's something squared. So I'm going to call that v squared, where v equals cos u. And we know immediately that dy dv would be 2v, yes, and dv dx would be minus, or not x, dv, wait a minute, dv du. Oh, that's so confusing. dv du would be minus sine u, because we're taking the derivative with respect to u this time. See, I was trying to be confusing, and I was. So let's chain rule it, right? dy du equals dy dv times dv du. Plug and play. What do you get? And then you substitute for v in terms of u, and there you go, right? So that looks like, oh, that looks suspiciously like a double angle formula. So I could call that, if I wanted to be fancy, I could call that minus sine of 2u. Isn't that good? Right, but you don't have to do that. You don't have to do that. You could just leave it like that and it would be perfectly fine. Yes, unless they asked you to express it as in a double angle formula, which would be very unlikely. Okay? Now this one, D, this one's a pretty interesting one, so we need to have a look at this one in detail. The derivative of log of mod x, and x can't be 0. X can't be 0, right? Now, let's just break that up a bit. Let y equal log of mod x. Now, what about if x was positive? Then you'd know that if x is positive, then x is the same as mod x, so therefore you might as well drop the mod sign and just say, well, it's going to be the same as log of x. Now, we know that the derivative of log of x is 1 over x from the first screen that we had in this video. So there we've got that one sorted out, yeah? That's basically no problem. But this is a bit different. Look, if y is less than 0, if x is less than 0, sorry, then y would be, now, why would this be? Why would this be? I'll show you. Just look, pick a value, a negative value of x. Let's say minus 2, yeah? Right? Let x be minus 2 as an example. Therefore, what would the modulus of x be if x was minus 2? Well, the modulus of minus 2 is just 2, isn't it? That would be the log of 2, wouldn't it? Okay, well now, meanwhile back at the ranch, what is minus x if x is already minus 2? It's minus negative 2, which comes to 2. So, see, this is 2, minus x is 2 if x is already minus 2, and the modulus of minus 2 is 2, so that the minus x and the modulus of x are the same thing if you have a negative value of x, alright? Now we're talking, aren't we? So now we've got to do the derivative of this beast, but it isn't x, it's minus x, so we have to call it blob, and the blob becomes a symbol, right? Log of u, where u is minus x. Now dy du would be 1 over u, and du dx would be minus 1. So therefore, by the chain rule, we know that therefore dy dx equals dy du times du dx, doesn't it? Which would be 1 over u times negative 1. Now, substituting back for what u was, it was minus x, wasn't it? Yes? So therefore you get that. Now look at that, isn't that extremely interesting, because the minus 1's cancel out, and you still get 1 over x as we got up there when x was positive. Alright? Look. So this is the very interesting thing, that the derivative of log of mod x, x can be negative or positive as long as you've got a mod there. You can't just have the derivative of x if x could be negative. You couldn't do that. So if you have mod, just to keep it from being negative, as long as it's not naught, as the question says up here, log of mod x, the derivative will be 1 over x, whether x is negative or positive. Very fascinating, isn't it? So that's something for you to take on board as well. That's something that you'll need to use in more maths to come. Okay, so there's the result, and you're a star. How did you like all that? You better probably go over it again. There's a lot that you may have learned in that session, and you need to be very, very well across it, so you need to do a lot of practice. Okay, thanks very much again for listening, and all the best to you. We'll see you next time.